Humanity still lives under the gentle light of the sun, but we cannot stay here forever. Right now, we are trying to transport our entire civilization. The environment that grew inside Earth's cradle must travel beyond it, to another world, and one day, across the stars themselves. Our first destination is Mars. Not as an extension of Earth, but as a place to recreate it. On that red soil, humanity will attempt for the first time to copy its own environment. To live on Mars is not simply to build a house. It is to recreate an entire environment. A challenge to rebuild the system that makes life itself possible. The surface of this planet is covered in iron oxide, stretching endlessly in red, dry sand. There is almost no moisture, and only faint traces of organic matter remain. Plant roots cannot grow, and even microbes struggle to survive. It is truly a land of trials for life itself. Yet scientists are searching for ways to bring life out of this harsh soil. Beneath the ground, ice lies hidden. NASA's Phoenix lander actually dug up ice just a few centimeters below the northern surface. Later observations suggested that in some regions, layers of ice may begin right under the surface and extend down several meters, or even tens of meters. For example, at Jezero Crater, once a lake, scientists report that frozen soil may still remain from shallow to middle depths. At such depths, robotic drills can easily reach the ice. Meanwhile, another strong candidate site, Oxia Planum, exposes layers of clay-rich terrain formed nearly 3.9 billion years ago. It is one of the best places to search for traces of ancient water and possible signs of life. Here, the focus is not on finding ice itself, but on studying ancient lake sediments and organic molecules preserved in the soil. If Jezero Crater is a place that holds the memory of lakes and river deltas, then Oxia Planum is where we read the records of ancient life. Both are witnesses of a once water-rich world that shaped the story of Mars. By melting this ice, we can obtain a precious source of water. Oxygen can be produced by splitting water through electrolysis, or by breaking down carbon dioxide using a MOXIE-type device. For agriculture, scientists heat or treat Martian soil to remove toxic perchlorates and add nutrients and carbon sources, transforming sand into fertile soil. Experiments have already begun, growing algae and even potatoes in simulated Martian environments. This marks the very first step of Martian agriculture. These farms and habitats are protected by expandable dome structures. After landing on Mars, robots unfold the multi-layered membranes delivered by rockets and fill them with pressurized gas. The outer shell, made of carbon fiber and Kevlar, blocks harmful radiation, while the inner layer acts as a transparent greenhouse. Underground, the water circulation system connects to the living quarters, maintaining balance. Inside, light and temperature are carefully controlled, and plants that create oxygen breathe gently. It looks just like a living artificial ecosystem. At the heart of this dome lies its power source, a micronuclear reactor. Even during dark nights without sunlight or fierce dust storms covering the base, this tiny heart keeps beating without pause. Electricity drives the oxygen generators, heat melts the underground ice, and the melted water begins to flow again. Energy circulates like blood, and the entire base starts to breathe like a living organism. This technology is also advancing in Japan. Systems like GE Hitachi's BWRX-300 and Mitsubishi Heavy Industries High-Temperature Gas Reactor, or HTGR, can operate for over 10 years without refueling. They are cooled by natural convection and can run autonomously even during emergencies. The same cluster control technology developed for small modular reactors on Earth could one day become the life support system of Mars. Of course, not every place on Mars is suitable for living. The polar regions are rich in ice, but they are extremely cold and have very little sunlight. Near the equator, temperatures are warmer, but the ice lies buried deep beneath the surface. That is why the first human colonies will most likely be built in the mid-latitudes, where ice is shallow and sunlight is easier to secure. Interestingly, this ideal zone overlaps with areas such as Jezero and Oxia, where both science and survival can meet. The dream of living on Mars is not just a fantasy. It is a grand experiment for humanity to learn how to survive beyond Earth. The technology that creates water, cultivates soil, and produces oxygen in extreme environments will eventually help us protect our own planet. Every step taken on Mars teaches us how to heal the Earth we came from. And in the end, what remains is hope. From the cold Martian sand, a single green sprout begins to rise. It reminds us that wherever we go, humans will always find the strength to live. Building a home on Mars means rebuilding the future of Earth, with our own hands, once again.